Hello and welcome to Cannon County High School Algebra 2. We have been working on probability the last week or so, and we have worked with, permutations and combinations and the counting principle. Today we're still going to be finding probabilities. The only difference is the data or the information that they give us in the problem is just going to be presented using frequency tables, which actually I think makes the problems a little bit easier. So that's good news, right? Mr. Lyon, I'm going to have you supervise us as always. Make sure we're doing things up to standards here. We are going to be using the same exact formula that we've been using for quite a while, and that is that the probability of an event is equal to the total number of outcomes for that event divided by the total number of outcomes possible. That's not changing. The thing that is changing is going to be how that information is presented to us. So I'm going to be looking today at, this is CC.6. Hopefully you can read that. There we go. CC.6, the problems are still just basic probabilities, and we're going to be using the same formula, but you can see that they're going to give us the information in what's called a frequency table. So let's take a look at that. This one says, a flight attendant was counting the number of passengers present to see if any upgrades could be offered. The flight attendant's list contained passengers' frequent flyer status as well as the number of bags checked. What is the probability that a randomly selected passenger has 0 checked bags and bronze status? All right, just like always, we want to try to figure out the denominator, and that's going to be the total number of possible outcomes. And a frequency table actually makes this pretty easy to do because all you have to do is count up all the numbers and add them up, and that is the sample space. So what we have here is the number of people with 0 checked bags and 1 checked bag, bronze status, and silver status. If you add up all of the possible outcomes, 1, 3, 5, and 1, you get 10. So there's 10 possible things that can happen, so 10 goes in the denominator. They want us to figure out what's the probability that a randomly selected passenger has 0 checked bags and bronze status. That word "and" is really important because that means they have to be both at the same time. They have to have 0 checked bags and they have to be bronze status. So if you look at this, I can see this cell right here is the only one where they have 0 checked bags and they are bronze status. So that means there's 1 out of a possible 10. And that's it. Now they want us to type this in as a fraction. It says to simplify any fractions, but 1 over 10 doesn't really simplify, so we shouldn't have to worry about that. And that's it. So let's try another one. Tim and his brother are at a store shopping for a beanbag chair for their school's library. The store sells beanbag chairs with different fabrics and different types of filling. Okay, so we have velvet and suede, foam and beads. What is the probability that a randomly selected beanbag chair is filled with beads and is made from velvet? So, how many things are in the sample space? Well, let's see. 5 and 3 is 8. Plus another 2 is 10, plus 4 is 14. So we've got 14 possibilities. What's the probability the randomly selected beanbag chair is filled with beads and is made of velvet? Beads and velvet. Well, let's see. Beads and velvet, those intersect right here at the number 3. So that means you have 3 out of a possible 14. 3 out of 14. Does 3 out of 14 reduce? I don't think it does, so I think we're going to stick with that. All right, let's skip up a level. Now that you've got the idea, let's jump up a level and see if these get any more difficult. Let's try this one. Mike works at a coffee shop on the weekends. Every now and then, a customer will order a hot tea and ask Mike to surprise them with a flavor. The teas are categorized by flavor and caffeine level. What is the probability that a randomly selected tea is caffeine-free or mint? All right, well, just like before, let's figure out the total number of things in the sample space. We've got 5 and 3 and 5 and 7. Let's see, those add up to how much? I think they add up to 20. So we've got 20 is going to be in our denominator. All right, this time the key word is or. Caffeine-free or mint. So let's see, caffeine-free, mint. If that said and, we would say caffeine-free and mint, there are 5. But it doesn't say and, it says or. So that means, let's say somebody is over here in this category. What if they wanted fruity and caffeine-free? Are they included in the number of outcomes for the event? They are, because as long as it's caffeine-free, they're good. What about if they are mint, but it's caffeinated? Are they included in the number of outcomes for the event? Yes, they are, because they are mint. The only ones that are excluded are the ones that are fruity and caffeinated, right? So in this case, you've got this 3 and this 5. As long as they're caffeine-free or mint, they're good to go. So how many things are included in the total number of outcomes for the event? Well, it'd be this 3, this 5, and this 5. So that's 13 out of a possible 20. 13 out of 20. And I don't think 13 out of 20 reduces. Okay? So you can see there's a big difference between the word and the word or. It makes a big difference, especially in these frequency tables. Let's try another one like that. Mike is a pediatrics nurse who conducts the first neonatal exam on newborn patients. He makes note of the newborn's height, weight, eye color, and heart rate, among other things. What is the probability that a randomly selected baby has blue eyes or has a fast heart rate of greater than 100 beats per minute? Okay, well, there's that word or again. So it's or means like if you're, obviously it can be both or one or the other. So let's see here. First of all, let's count up the sample space. 4 and 7 and 5 and 4, what do those add up to? I think they add up to 20 again, so that makes it easy. Let's see, what's the probability that a randomly selected baby has blue eyes? Well, how many have blue eyes? There's 5 and 4 that have blue eyes, so far 9. Or has a fast heart rate. Fast heart rate is in this category, so that means 7 and 4. Okay, so we've got 5, 4, and 7. The only babies that are excluded are those with brown eyes and have a slow heart rate. So it's going to be everybody except those 4. So it's going to be this 5, this 4, and this 7. So 5, 4, and 7 add up to 16. 16 out of 20. 16 out of 20. Now be careful. You know that IXL is really, really picky about typing in fractions or decimals. The fractions always have to be in simplest form, and the decimals have to be rounded correctly. So what does 16 out of 20 reduce to? I think it's 4/5, right? 16 out of 20 reduces to 4/5. Try that on your calculator just to make sure. But I think we got that right. Yep, we did. All right. Let's jump up another level. Let's see how we do here. We're up to 49. Let's see what we get here. Dan just returned from a spring break volunteer trip. He is shopping for a photo album that will showcase his photos from the trip. The albums range in photo capacity and orientation. Well, you can tell whoever wrote this problem is living in the past because nobody does photo albums anymore. Just kidding, maybe you do, I don't know. We used to, but we don't anymore. Everybody just keeps them on their phone. What is the probability that a randomly selected photo album holds exactly 100 photos and is oriented horizontally? And, so that means it has to be both. It can't be one or the other. It's got to be both. So let's see. First of all, how many are in the sample space? So 3, 1, and 5, those add up to 9. 2, 7, and 2, those add up to 11. So 9 and 11, that's 20 again. I'm sure not all the problems have 20 in the sample space, but we've been on a roll here lately with the number 20. So let's see. What's the probability that a randomly selected photo album holds exactly 100 photos? So we're definitely in this row. It's got to be 1 or 7. And is oriented horizontally. Horizontally is this row. So the only one that has 100 and is horizontal is 1. So that's 1 out of 20. Again, the key word here is and. If it would have said 1 or 20, well, then we would have included everything in the 100 row and everything in the horizontal row. All right, let's see here. At a science museum, visitors can compete to see who has a faster reaction time. Competitors watch a red screen, and the moment they see it turn from red to green, they push a button. The machine records their reaction times and also asks competitors to report their gender. Okay, what is the probability that a randomly selected competitor reacted in over 0.7 seconds or that they were female? So there's the word or, so we know it can be one or the other. It doesn't have to be both. Let's first figure out how many things are in the sample space. Let's see, 2, 2, 2, that's 6. 6 plus 3 is 9. 9 plus 1 plus 2, that looks like 12. So we've got 12 items in the sample space. How many of them are over 0.07 seconds? Over 0.07 seconds, we have 3 total. We got this one and those 2. Or was female. Female, it looks like we have 7. So we've got 2, this 3, this 2, and this 1 that belong in the numerator. So what do all those add up to? I think they add up to 8, right? 2, 3, 2, and 1 add up to 8. And how many did we say were in the sample space? 12. So what's 8 over 12 as a fraction? I think that does reduce. What does 8 over 12 reduce to? I think it's 2/3. Try that on your calculator if you're not sure. But I think that comes out to 2/3. Let's jump up one more level. Let's do one more problem, see how this goes. I think you're getting the idea now. The biggest thing here is just making sure you understand the difference between and or. Bernard keeps, all right, we're at 75, so we're pretty close to 80. Bernard keeps all his spare keys in a box under his bed. Recently, Bernard decided the box was becoming unmanageable as none of the keys were labeled. He set about labeling them with colored stickers that indicated what each key opened. So let's see, we've got the front door, the back door, the car, or the safety box with either a blue sticker or a green sticker. What is the probability that a randomly selected key is not labeled with a blue sticker and does not open the back door of the house? Okay, I can see why this one is up there in level a little bit, because once you start putting in the word not, that changes things, okay? Kind of like when you're trying to be confusing to your friends and you say, well, I'm not mad at you. Once you start putting the word not in front of things, especially with frequency tables, it makes it a little more complicated. But I like the word and here because that means that it's got to be both of them. It can't just be one of them. So this should be easier for us to count up. We just got to be careful with that word not. So let's see, what's the probability that a randomly selected key is not labeled with a blue sticker? Okay, if it's not labeled with a blue sticker, then what label is it? It's green, right? So this is just a fancy way of them saying it's got a green sticker. And does not open the back door of the house. Okay, so the only thing, so it's got to be green, we know that so far, and it cannot open the back door of the house. So that means we're going to exclude this 12 from the greens because that one does open the back door of the house. So how many are green and are not opening the back door of the house? It would be this 9, this 0, and this 1. So 9, 0, and 1 add up to 10. So that means a 10 is going to be in our numerator. And one thing I think I neglected to do is actually add up everything in the sample space. So what is 13, 11, 4, 6? Oh boy, okay. Maybe I'll bust out the calculator for this one. What is 13 plus 11 plus 4 plus 6 plus 9 plus 12 plus 1? It gives me 56. So that means in the denominator for this one, or actually for the numerator again, we're going to have the 9 and the 0 and the 1. And in the denominator, we've got 56. So 10 out of 56. All right, let's try that. What does that reduce to? 10 out of 56. Does that reduce? Let's ask our calculator. As long as our calculator is the one doing all this. 5 out of 28. There we go. So the answer is going to be 5 out of 28. So you can see if they put the word not in there, it makes it a little more complicated, but use your common sense and I think you'll be able to figure these out. Okay? We didn't check to see if we got that one right. We did. All right, awesome. All right, well, that's it for today. I hope that this helps. Give these a try. This is CC.6. go on IXL and give those a try if you want and see if you can get up to 80. Okay? Thanks for watching. We will talk to you next week. Have a great weekend. Bye.